Welcome to 1.10, acceleration. When we step on the brakes, we go slower. That means that velocity goes down, decreases. When we step on the gas pedal, we go faster, velocity increases. In both cases, we have acceleration. But what does acceleration mean anyway? Well, acceleration in different languages. We know that when something is fast, we have a large velocity. When something is slow, we have a small velocity. We know that when we go faster or slower, we have acceleration. But what does large acceleration mean? What does slow acceleration mean? Well, here we're going to have two cars. Everything's the same. So we have a red car and we have a blue car. We see two cars here. The only difference is the acceleration of the blue car is 3 and the acceleration of the red car is 1. Let's see what happens. At the beginning, they're both slow. They're both getting faster. That's why the position graph looks like a curve. But the blue car is speeding up faster than the red car. When that happens, the blue car has larger acceleration than the red car. Okay. So with this example, the car is speeding up but slowly, so it's a small acceleration. Here, the car is speeding up quickly, large acceleration. One more simulation. This time, the red car travels in constant velocity, the blue car constant acceleration. Okay, here we go. So at the beginning, the red car is faster and it's traveling at constant velocity, but the blue car is going faster and faster and faster, and eventually the blue car is faster than the red car and finishes first. So red is constant velocity, blue is constant acceleration. Some vocabulary. Initial means start, final means end. Here we have a word academy. The initial, that means the first letter, is A. The final letter is Y. So in this lesson, we will talk about initial velocity and final velocity. In our example here, the final initial velocity of the blue car is 0, but the final velocity of the blue car is 33. The initial velocity of the red car is 0. The final velocity of the red car is 11. So the velocity is getting higher and higher. Example. The initial velocity of Chang's car is 30 miles per hour. So this is VI, initial velocity. Her car accelerates at 20 miles per hour per second. What is the final velocity after 4 seconds? Well, initially it's 30. Every second, if the acceleration is 20 miles per hour per second, that means every second it goes up by 20. So it's 50 miles per hour after 1 second. 70 miles per hour after 2 seconds. 90 miles per hour for 3 seconds. And we know we want 4 seconds. So after 4 seconds, the velocity is 130. So final velocity is 130 miles per hour. So probably not realistic. The car probably won't speed up that much. But we know that the initial velocity is here. The acceleration is how much the velocity changes every second. Okay. Next one. If we have two cars, they both have an initial velocity of 30. The time is 4 for both of them. But the first car has acceleration 10, the red one. The blue car has acceleration 20. What's going to be the difference? Well, when the acceleration is 10, we go up by 10 every time. When the acceleration is 20, we go up by 20 every time. So even though they both started at 30, the blue car with more acceleration ends a lot faster. The red car ends at 70, the blue car ends at 110. Finally, if the velocity is going up like this, that means it's going up by 10 every second. It's going up by 10, going up by 10. That means that the acceleration has to be 10. And here we have, here we have meters per second. So it goes up by 10 meters per second every second, right here, which is also equal to 10 meters per second squared. Okay, that's it.